Good morning, this is Dr. Gondi Kondareddy. I would like to explain about projection of points, the importance of projection of points in engineering drawing. So far we did the drawing, 2D drawing, that is the drawing that is having length and breadth. So if you are taking triangle or polygons, any kind of thing, that it is having the dimensions of length and breadth. But just assume then solid which is having 3 dimensions. Solid generally it is having 3 dimensions, length, breadth and width. So my question is, how we can draw the solid on 2-dimensional drawing? Because drawing sheet is having only 2 dimensions. We are able to draw this solid on a 2-dimensional drawing sheet. How we have to do it? To have that, we have to have the concepts of projections of these solids. So to know the projections of the solids, we have to have the knowledge of projection of planes, because it is a combination of number of planes if you are taking solid. Likewise, you wanted to have the knowledge of drawing, we have to have the knowledge of straight lines. If you know that, if you require to have the knowledge of straight lines, you need to have the knowledge of projection of points. Now I would like to I would like to tell you what is meant by projection of point is. We know the projection of point is one, where now I'd like to tell you what is meant by projection of point is. Point is one which does not have any mass as well as it does not occupy any area. Very, very minute kind of thing that we are imagining for the analysis. So that we have to assume as a point. First we have to know how we have to draw the point in a universe. So I am dividing this entire universe into 4 quadrants. See, vertically I am writing VP, vertical plane. Horizontally I am writing horizontal plane. So we have to identify where the point is. Let us say the point is in first quadrant where I am showing here. So here we can say the point, let us say that is there at that particular place. We can say the point is in first quadrant where it is in front of vertical plane, above horizontal plane. Likewise we have told you. Let us say the point is in second quadrant. See here, it is backside of vertical plane, above horizontal plane. That we can say the point is above horizontal plane, behind vertical plane. Likewise, the third quadrant where the point is behind vertical plane and below horizontal plane. Likewise, fourth quadrant where the point is in front of vertical plane and below horizontal plane, like that. The point we can decide. Now, I am coming to the first quadrant. If the point is there, let us say point A is there in first quadrant, that is the meaning of the point is above horizontal plane, in front of vertical plane. How we have to draw it, right? So I will tell you one example. If your point is 20 mm above HP, 30 mm in front of VP. So if it is there like that, it is understood that the point is there in first quadrant. It is 20 mm above HP. So when it is 20 mm above HP, directly the front view falls on VP line. So if it is 20, it falls directly here. It is on vertical plane. A point, no? Small a dash. Vertical plane generally we are indicating with dash. So it is the front view. Then top view it falls like as this at certain plane here. So it is A. It is top view. So this how we have to draw it on a 2-dimensional drawing sheet. So vertical only. Horizontal, we have to rotate always this horizontal plane 90 degrees clockwise. The way I am showing with the arrow, it has to come down. So that means the front view, 20 mm above XY line, we have to write A dash. And this top view, where whatever it is as it is turning like as this, it will come down. So front view is here, top view is here. So it is falling on the same line. Horizontally we have to write XY line, where X is this side, Y is this side. Likewise we have to show. It is just example likewise I am saying. If you are going for other point, let us say I am taking one more point, B point here. B 20 mm above HP, 30 mm behind VP. As I am saying this question, the point falls in second quadrant. So above 30 mm, so it falls at this front view, top view falls on this. So here where we are getting front view and top view. Front view above XY line only, Top view, this one we have to rotate 90 degrees clockwise. Being it is clockwise, we have to rotate upside. That means front view is above xy line and top view is also falling above xy line, likewise. Let us say coming to third quadrant, if your point is in third quadrant where the point is below HP and behind VP, let us say 20 mm below HP, 30 mm behind VP. Below HP in the sense it falls at this point, below 20 mm below HP, so this front view is false here because we are seeing always from this side, always from this side, it is front view. The top view when you are rotating it comes up, so the top is goes up and front view comes down like that. If you are seeing in fourth quadrant, what happens is the question may be like this: the point is below HP, in front of VP. When in front of a distance, it falls at this place, and regarding top view, it falls here. When you are rotating, it will come once again downside. So the both top view and front view falls on below xy line. So it is understood that in first quadrant, front view is upside, top view is downside. Then second quadrant, both front view and top view falls above xy line. In third quadrant, the front view is below xy line, the top view is above xy line. In fourth quadrant, both front view and top view falls below xy line. One thing I would like to tell you here, if you are seeing here generally, in first and third quadrants, front view and top views are separated by xy line. If you are seeing in first quadrant, the front view is above xy line, the top view is below xy line. In third quadrant, the front view is below xy line, the top view is above xy line. These are useful two quadrants we can use for drawing. If you are considering second and third quadrant, generally we are not considering second and fourth quadrants. What is the reason is, if you are seeing in second quadrant, both front view and top view falls above xy line only. Because front view itself is a big cumbersome drawing and top view is also falling on the same thing. Finally, it is not looking good. We are unable to understand. Same thing happens when we are thinking about fourth angle projection, where if top view and front view falls below xy line. But it is not happening in first and third quadrants. Generally, it is universally accepted kind of drawing is first quadrant system. When you are assuming the drawing is in first quadrant, when the object is in first quadrant, we are drawing front view above xy line, top view below xy line. This kind of system we are adopting nowadays. Universally it is accepted. Third angle projection also we can use it because front view falls somewhere and top view falls some other way. So we can also adopt this, but generally universally accepted nowadays is first angle projection. We are not going to use second and fourth angle projection because both front view and top view, they are coinciding either in above xy line or below xy line. Only we are using first quadrant and third quadrant drawing. If you are using the drawing in first quadrant, it is called first angle projection. When we are using the drawing in third quadrant, it is called third angle projection. As I am saying, nowadays we are using first angle projection where front view falls above xy line, top view falls below xy line. This is how we have to learn from the fundamentals. Thank you.